Alrighty, let's practice our SOHCAHTOA trig sine, cosine, tangent stuff a little more. It's good to do this because we're going to need all this sine, cosine, tangent stuff in the next unit in a big way, and that's an electrical unit, so it is important to electricity, even though this doesn't look electrical. But anyway, this is your homework, and I'm going to actually, there's 10 problems on here, word problems, I guess, if you want to just say it that way. 10 good problems is what I would say. And I'm going to do 3 of them to get you a nice start on your homework. So I'm going to do problems 1, 4, and 7. Here's problem 1. And already we have a new thing to learn. What does angle of elevation mean anyway? So I need to define that. Angle of elevation is measured from, and this is important, it's measured from the horizontal. The horizontal might be the ground, but it doesn't necessarily have to be the ground. Just picture yourself looking straight out horizontally. So this is you, and this is your eyeball right there. You get a nice big eyeball. And so if you were to look straight ahead, this is the horizontal direction, right? This is the horizontal. Angle of elevation would mean that angle right there. That is the angle of elevation. It's always measured from the horizontal. That's the part to keep in mind. Always, always, always. Sometimes, if I say angle of elevation, you wouldn't say this angle. No, 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 no. It's from the horizontal, always. And, while we're at it, while we're drawing diagrams like this, you might see that in the next problem, there's something called angle of depression. Kind of the same thing, except your eyeballs are going down. So this would be the angle of depression. Again, it's measured from the horizontal. That is the big deal. Okay, you measure from the horizontal. Okay, in fact, you know what? I'm going to keep that shaded in because it's that important. So let me just kind of maybe, what I'm going to do? I'm going to try to shrink and move that over a little bit. Shrink, come on. What is this thing? Shrink. Okay. Shrink and move that over a little bit so it's not so much in our way. Cool. All right, so let's solve this problem, why don't we? The angle of elevation to the top of the Empire State Building is 11 degrees from the ground at a distance of 1 mile from the base of the building. Using this information, find the height. How tall is the building then? Okay, let's draw the ground. Let's get a different color. Make this clear that how I'm working on the problem. There's the ground. And here's the Empire State Building, I reckon, right about there. And it's pretty tall. And the angle of elevation to the top of the building, so you have to picture yourself sighting through the top of the building here. The angle of elevation, which again, it's measured from the horizontal, right? So the ground is horizontal, we presume. And so this angle here, raising up from the ground, that's an 11-degree angle. That's what we mean by angle of elevation. Okay, cool. So the angle of elevation to the top of the Empire State is 11 degrees from the ground at a distance of 1 mile or 5,280 feet from the base of the building. So this is 5,280 feet right there. Using this info, find the height of the building, which would be like this X right there, right? Wow. Does that look like a familiar kind of situation? That's kind of like a right triangle thing, right? That's a 90-degree angle. The building's standing straight up. So we've got this side is 5,280. We want this side, and we know this angle. Cool. SOHCAHTOA is going to be perfect for this. So we're going to have to use the 5,280 somehow. We want to get the x somehow, which means we're crossing these two sides. Do you know which trig function crosses those two sides? It's either sine, cosine, or tangent. You might remember tangent is the TOA part. It involves opposite and adjacent, which is what this is. This is the opposite coming over the adjacent. This is a tangent situation. Cool. So we can actually just solve this problem by writing. Remember, the tangent of an angle is the ratio of its opposite over its adjacent. So the tangent, in this case of 11 degrees, is equal to its opposite, which is x, over its adjacent, which is 5280. You can put that over 1 if you want, and then say cross products 1x is equal to, multiply these two things, 5280 times the tangent of 11 degrees. That didn't take so long to do. Let's just type that out, or type that in. 5280, tan button, 11, boom. To the nearest foot, it says, so I'll round this number to the nearest foot. It's just about 1,026 foot tall. Pretty cool. Now, I didn't take into account whether I'm looking at the antenna or not, but that should be pretty accurate. Again, I don't remember if it includes the antenna or not, but it's supposed to be accurate. 1,026 feet. So what's the hardest part about this problem? The hardest part about this problem, probably, how do you do a redo on this thing anyway? I should learn that someday. So it's 1,026 feet tall. Yep. Okay, so the hardest part, I think, was figuring out that it was a tangent that we needed. And you get two ways of doing this again. You can either do the old, it does not involve the hypotenuse, therefore it's the tangent. Remember, tangent does not have an h in it. TOA does not have an h in it. So the one without the hypotenuse is the tangent. And you might also remember that you have to be careful because the tangent will hit you in the face. And so that's, sounds like a lot, but that's kind of how I figure it. That's the tangent right there. The other way, of course, is to label your sides. And you say, well, that's the hypotenuse, I know, because it's the big side. And if I'm over here using the 11, that's my point of view. Walking through the middle of the triangle to the other side gets you the opposite side. And I'm basically standing on the adjacent side. And then that's how you can figure out, oh, I'm using an opposite and adjacent, an O and an A. I'm using a tangent. Tangent is x. Tangent of 11 is x over 5280, just like we said here. Okay. Well, you get the feeling this trig is useful stuff, right? It's like you could use it. Surveyors use it all the time, of course. And remember this angle of elevation, angle of depression. So problem 2 has an angle of depression, but actually so does problem 4. So I might as well just do number 4. Problem 4. What do we got here? It's a slightly bigger problem. It's got 4 lines to it. A woman is sitting in a tree and she sees a flagpole. The horizontal distance from the woman to the flagpole is 60 feet. And where she's sitting, has an angle of depression, which means she looks down, to the bottom of the pole, 14 degrees, and an angle of elevation, which means she looks up to the top of the pole, is 8 degrees. Find how tall the pole is. Okay. So it's always good to draw it out first. Make sure you get a really solid understanding of it. You can anchor your math on it too, which is another nice thing. So we got a tree. I suppose I could draw the tree. Let the artist in you take over, right? There we go. So I'm going to put the woman right there because I'm not going to let the artist do anything else. There's the woman right there in the tree. She sees a flagpole. Where's the flagpole? Well, let's assume the ground is level. That's usually a pretty good assumption. She's the flagpole over there somewhere. Okay, cool. The horizontal distance from the woman to the pole is 60 feet. So that means that if you were to sort of like drop a horizontal to the ground here and measure along the ground, this distance is 60 feet. Funk, funk. Okay, we got something. We got a dimension. Cool. Now what else do we know here? From where she sits, the angle of depression to the bottom of the pole is 14 degrees. Now remember what I was saying before. Angle of depression, angle of elevation are always measured from the horizontal. Her eyeball is over here someplace, right? That's where her eyeball is. Her horizontal looks like this. To her, that's horizontal. So she has to kind of depress her head, look down to see the bottom of the flagpole. And it says the angle of depression is 14 degrees. So that's that angle. And then she has to look up, the angle of elevation to the top. She has to elevate her head or has to look up, again, from the horizontal, 8 degrees. So that's an 8-degree angle right there. Okay, cool. Well, that's the given information. And then what are we asked? We're asked to find how tall is the pole to the nearest 1/10 of a foot. Okay, how tall is the pole? So we got to figure out how high that flagpole is. Now, here's the problem. with the problem here. Here's the problem with this problem. We got a beautiful triangle here, but it's not a right triangle. None of those angles are 90 degrees. Oh. So you can't use the big triangle and do any SOHCAHTOA stuff. It won't work. So what you got to do instead is you got to say, well, I do have right triangles. I have two of them because this is straight across and the flagpole is straight up. So that's a 90 and that's a 90. So you have to actually break this problem up into two separate problems, kind of. You need to find like what's the height from here to here, and then you have to find what's the height from here to here. You have to find this side of that triangle and this side of that triangle. You have to find the x and the y. You got SOHCAHTOA twice, is what I'm saying. SOHCAHTOA twice. So let's get a good color. That's not that good of a color. Let's get this color. Okay. This color, this color, this color, this color. I got an 8-degree angle. I want the y. Can I use the 60? Sure, I can. Because the 60 is measured straight across, and so actually that's also 60 feet right there, right? That's a straight up. That's a straight up. So yeah, it's 60 feet straight across there. So cool beans, man. I got the y, I got the 60. I need to use the y and the 60. I'm not using the hypotenuse. Can you smell a tangent happening here? This is a tangent. The tangent of 8 degrees is the opposite, which is y, over the adjacent, which is 60. So if you were to do a crisscross applesauce type proportion thing, you'd have 1 times y equals 60 times the tangent of 8 degrees. And you can push buttons. This is great. 60 times the tangent of 8 is, make sure you're in degree mode. Yep, shift, set up 3, right? Anyway, I got 8 point, it says nearest tenth of a foot, but I'm in the middle of my calculating, so I like to carry a couple extra. 8.432 feet. That's my y. Now I could do the same thing to find x. I'll use a different color this time. What haven't we used? Gray. We haven't used gray. So looking at the not black. Okay, looking at the 14-degree angle, I want the x. I got the 60. I'm crossing this way, and that's also a tangent, right? Cool. So I can say that the tangent of the 14-degree angle is its opposite, x, over its adjacent, 60. This is the same kind of crisscross applesauce type stuff. X is equal to 60 times the tangent of 14. And that's a degree symbol. So you go 60 times the tangent of 14. And you get just about, again, I'm going to carry a few decimal places with me. 14 point, well, if I go to 3 decimal places, it says 9596, which means it's going to round that up to a 960. 959 goes to 960. So 960. And that's my x. So my x is over here. It's this is my x right here, 14.960. Add on the y, which we already solved, was 8.432. And we got a height of the flagpole is 14.960 plus 8.432 is 23.392. Okay, now I'll round to the nearest tenth of a foot. So rounding to the nearest tenth means I want to round here, right? The 9 makes me round up to a 4. The 3 rounds to a 4. 23.4 feet. And that's part of my answer anyway. That flagpole to the nearest tenth of a foot is 23.4 foot tall. Now just to finish, here's a good habit. Always go back and look at the question again and make sure you've answered all the parts. See, there's something else we got to do here. We need to find feet inches. Well, it's 23.4 feet, so it's definitely 23 feet. Do you remember how to turn 0.4 feet into inches? You do the old 0.4 times 12 trick. 0.4 is like 40%, that's what it means. And it's 40% of a foot. And a full foot is 12, so it's like, what's 40% of 12? Well, you go 0.4 times 12. Just take the decimal times 12 is what I'm trying to say. And that would be, well, I got 4.8 inches. So it's 23 foot, maybe 5 inches or something. Okay. Cool. Cool. So I've used angle of elevation, I've used angle of depression. Tangent comes up a lot in these things I've found. It's not guaranteed, it doesn't always. You don't always use a tangent, but it's amazing how useful the tangent is. Comes up a lot. Okay, so that's 2 problems, and I wanted to do number 7 as well. If you look at number 6 for just a second, it's talking about airplane flying in elevation on a highway. There's cars and stuff, the angle of depression, blah, 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 blah. That's a good problem. So I'm going to do this one, which is a little bit simpler. But it's similar. It's got the angle of depression. It's got the hot air balloon. It's above a road. So in that sense, it's kind of a similar problem. Let's go back to blue for a while. Okay. There's a hot air balloon. It's floating above a straight road. The balloonists want to estimate their altitude in feet. How high up are we, folks? So when they're hovering directly over mile marker 24, they must have binoculars or something. They say, "Hey, that's mile marker 24, right there underneath us." So while that's happening, they measure the angle of depression to the next mile marker 25. So that would, of course, be 1 mile away, right? Mile 24 and mile 25. That's a mile away. If this angle of depression is 34 degrees, what is their altitude? Okay, we can start solving. The rest is just a PS. The distance between mile markers is a mile. And PS, a mile is 5280 feet. Let's draw a little diagram here. That's the road. Here's our hot air balloon. Got a little basket or something here. Got a bunch of strings or something. There's our hot air balloon. And it's above, directly above, mile marker 24. Did you ever see the mile markers on the side of the highway? They're cool. You could use them to see how good your odometer works. It's like, hey, my odometer says I went 2 miles, and that says I went 3 miles. No, it's not going to be off that much. Anyway, when the balloon is hovering above mile marker 24, they measure the angle of depression of mile marker 25. Here's mile marker 25 over here. It's got a 25 on it. Okay, mile marker 25, right there. They measure the angle of depression, which basically means they're looking down at it. Mile marker 25. And this is not necessarily the scale or anything, but that's their angle of depression. No, where's their angle of depression is what I should say. There's a 34-degree angle of depression somewhere. Where is it? Were you thinking there? No. Yeah, go back to what I was saying before. It's always from the horizontal. You measure the angle from the horizontal. So if you're up here in the balloon and you look in the horizontal direction, you're looking this way, right? That's the horizontal. You're depressing your head by 34 degrees is what that means. Angle of depression 34 degrees means that's 34 degrees right there. Okay, so be careful about that. Be very careful about how you interpret these things. The angle of depression is right there, 34 degrees. Now, what was it we're solving for? The altitude, which means basically we're solving for that side. And what do we know? We know that it's a mile from here to here. And we also, if we want to work in terms of feet, which sounds like a good idea to me, it's 5280 feet. There we are. So we got 2 sides and we've got an angle sort of. So we want to somehow use this side and this side with a trig function. Now here's the thing, that 34 degrees is not really inside of our triangle. You need to have an angle that's like actually inside of your triangle. So I got a good trick for you. You remember anything about alternate interior angles? Ooh, catchy phrase, man. Catchy phrase. This is parallel to this, right? So if you look at a line that crosses 2 parallel lines, this and this are called alternate interior angles, and they have to be the same. So that's a 34-degree angle right down there. So let me erase some of this stuff now. I love being able to clutter up my diagram and then unclutter it. It's cool. So that's a 34-degree angle right there. Blink, blink, blink. So we're going to use that angle. Now, by the way, if you wanted to, you want to be a rebel or something, you could also figure out this angle you could say, well, that's a 90. So if that's 34, this is 90, take away 34, which is what, 56 degrees? And then you could use this angle instead. The way you set up your equation will be different, but you'll get the same answer in the end. But I'm not going to do that. So I'm going to stick with my 34 down here. So getting back to my 34 angle down here, this side, well, again, I'm not using the hypotenuse. If it's not the hypotenuse, it's not the tangent. You want to get hit in the face, but not quite. That's the way you cross the triangle to form a tangent. X over 5280 is the tangent of the 34 degrees. I can write that out. The tangent of that angle is X over 5280. And of course, you can label sides and do it that way. You can say that's the hypotenuse, that's the opposite, because I had to come through the triangle to get to the opposite side. This would be the adjacent. So we're playing with opposite and adjacent. That's an O, that's an A, that's a TOA. And so we use the equation that the tangent of theta is opposite over adjacent. And I've already plugged into it. So tangent of 34 is equal to X over 5280. We are so almost done. I'm going to do the crisscross applesauce. 1x is equal to take 5280, multiply it by the tangent of 34 degrees. What do I got here? 5280, multiply it by the tangent of 34 degrees. And what I'm looking at is 3561.4. Does it say to round? It doesn't say to round. I guess that's 4 sig figs, right? 5280 feet is an exact conversion. This is supposed to be exactly a mile. I guess we could use 4 sig figs, or maybe even an extra sig fig just for fun. It's about 3561 feet. 0.4. Cool. Was that number 7 already? I did 3 already? Cool. Well, this is like, measuring a height over a cloud, and it's all similar stuff. There might be a little bit of a challenge problem in here somewhere, but you get the idea. We're using our SOHCAHTOA again. Lots of tangents, but sine and cosine will happen, so make sure you know your SOHCAHTOA and stuff like that. Cool. Thus endeth the trig unit.